Hello everyone, today we will make the remote control car with ESP32 and Bluetooth, and I will explain you the circuit diagram and then the code and then the actual configuration of the circuit. I'm going to keep it very short. I have kept the concept for around like less than 15 minutes, and then the video after that is for the actual assembling of the circuit in fast forward motion. So let's begin with it. Okay, so let's start with the basic understanding of the main components, their working, and the circuit diagram, of course. And that is the main thing, actually, to understand how to make an RC car. So what do you need for making a remote control car? First thing, you need a motor driver. I'll tell you what it is exactly. And then you need a microcontroller. We are using ESP32 right now. You can also use ESP8266 or Arduino. But in this tutorial, we are going with ESP32, basically dev kit v1 version, and you need a car chassis. So if you've got a pre-assembled one like this, that's great. If not, you must get something like this. You must have like 4 or even 2 motors. It's not necessary to have 4 motors, and some wheels. Can be 2, can be 4, can be 3. So just assemble it like this and put the motors there, put the wheels at the end of the rotating shaft like this here, put the wheels over here, and just assemble it like this. And what next? You need some jumper wires or maybe simple wires, whatever. You need a battery, or if you have a socket like this, you can just put in the cells, and a breadboard. It's not compulsory. I am going to use it so that the circuit configuration is easier, but you can make it without a breadboard as well. If you have jumper wires which are female to female, you can just connect these pins with each other without using this. So the exact motor driver that we will be using is this L298N H-bridge motor driver. How does it work? So basically, these are the input pins and these are the output pins. It takes power from the input pins, and basically this 12 volt will be connected to the battery. This ground, of course, will be connected to the negative terminal of the battery, and the 5 volt goes to ESP. And what happens is actually the maximum power it can take is 12 volts. So if you give it more than that, it will burn. So be careful with that. And the motors that we are using the cheapest one out there. So their operating voltage is somewhere between 3 to 6 volt, or maybe something like this. So you have to check whenever you get a motor. These motors, I'm talking about these. Whenever you get a motor, you have to read the description. You have to check the operating voltage before giving it power. So basically, it takes the input and then it gives the output from these terminals to the motors. So what we will do is, let's say these 2 terminals, out 1 and 2, we will connect it to the left motor. Out 3 and 4, we will connect it to the right motor, and we will set one of these as high and the other one as low. For example, out 1 is high, out 2 is low. So due to the difference in the polarity, the current will flow and the motor will start rotating in one direction. And if we reverse that polarity, for example, out 1 is now low and out 2 is now high, which is the opposite of the one of the configuration that I just told you, opposite of the previous one, it will start rotating in the reverse direction. So that's how you control it. You move it forward or backward. Now these are the output pins, right? Okay, my pointer is not working very good. So these are the output pins. Now what about these? These, you can say, this is where we set the logic of how to control these motors, right? These are the input pins. We will connect these pins to ESP and we will control the logic from these pins. Basically, in1 to in4 will control the logic, and ENA and ENB, these are the enable pins. These are configured for the speed. Okay, now let's see how to exactly connect the circuit, how to do it. So the output pins will be connected to the motors. So out 1 will be connected to this terminal, and this is where I was saying you have to solder it. Out 2 will be connected to the other terminal. It's not visible right here in the picture. So you have to solder the pins over here, because when the car will move, it may move if you won't solder. So, and that will be annoying. So just solder it one time, these pins, and these pins on the motor driver, they will be configured with a screwdriver. So you have to put the pins inside and then move the screwdriver. I'll show you how to do it. I will assemble the circuit in front of you. So right now I'm just connecting the pins to show you how everything goes. And same is the case here. These pins will be connected over here. Okay, so the 12 volt will be gone to the 12 volt of the battery, and the ground will be connected to the ground of the battery, and ground is common, by the way, so that means we will also put it here in the ground pin of ESP. Next thing is 5 volt. These 5 volt, this pin will be gone to the ESP, to the V in of the ESP here. Okay, now comes the in 1, 2, 3, and 4 pins. So we will start connecting them like this. With D2, in 1, with D4. By the way, this is not fixed. You can change the order or the pins. You just have to put the pins over here and use the same pins in the code. So don't it's not fixed that you have to use just these pins. Whatever pins you use, just use those ones in the code. Into connected to D5. I have written the code for this one. That's why I'm connecting these pins. Then we have in 3. Okay, so our circuit diagram is complete. Is there anything else? This ground was common, so don't forget that. It's going to the motor, it's going to the battery as well as to the ground of ESP32. That's it. By the way, sometimes a jumper is used in these two pins. So if you connect these two, that means you will just run the motor at full speed. But if you want to give it some power, some custom speed that you want, you can do that by just connecting this pin and remove this jumper. Don't connect this jumper, of course, otherwise this won't connect. So this is the circuit diagram. Now let's see the logic and code, and that's it. Then we will move towards assembling the actual circuit. Okay, so let's see the code. This is the easiest possible code there can be. First thing first, include the Bluetooth library. Of course, we are making a Bluetooth car. That means we need the Bluetooth library, and then make a variable of Bluetooth serial class. Okay, the next thing is define the ports, the pins. Define the pins, and of course we have defined them in the same manner that we configured the circuit with. So if you are using some other pins in the circuit, just change them here. That's it. Next thing is the speed. For now, just understand that this is between 0 to 4095. And why 4095? It has something to do with the PWM, pulse width modulation. I'll explain why. Okay. Next thing, by the way, I've written the code beforehand just to save the time. So next thing is we are setting up our code in void setup. So begin your serial with this frequency, and begin the Bluetooth, right? And if whatever you write here will appear in the Bluetooth devices of your phone or the app that you will be using later on. Okay, and this is just to see that it's working. This will be printed on the serial monitor. By the way, I'm assuming that you are already familiar a little bit with the Arduino programming language. I hope. So I'm not explaining what println is and so on, and what this frequency means and so on right now. If you want to understand that, I have another video on ESP. You can check that out. Okay, so next thing is we are configuring the pin modes. So ENA is output. All of these in 1, 2, 3, 4 are the output pins for ESP. For ESP, these are output pins. For motor driver, these are input pins, right? Okay, let's go to the loop function. So first of all, we will check if Bluetooth is available there, the Bluetooth is connected. If it is connected, we will read something from the Bluetooth, a character variable, and we will store that in the value. And based on the value of this character variable, we will be running some functions. These are the functions. So if the value is F, that means forward, we will run the forward function. If it is B, that means the backward function, left and right, and so on. By the way, we can use this code with any app on the Play Store. I have tested this code with 2 apps and I will name them in the description, but you can use it with any app. Usually all of them works, and usually what happens is they provide you with a remote for the RC car, and that remote has several buttons, for example, forward, backward, left, right, and pressing any button sends a character through the Bluetooth, and it will be received over here, and while F is received, you will just call the forward function. So this code works. And sometimes in the app you can configure them so they are customizable. That means you can set the character that can be sent. It can be F. Sometimes in some apps it is U, that means up, and D for down. So that's why I've written these over here. So I think you got the gist. How is it working? How does this thing work? In very simple words, the Bluetooth remote control app, you will download it from Play Store. You can use any of those. I will tell you the names of 2 which I tested, and then those remote control will provide you with the buttons. You will press those buttons, and whenever you press a button, for example the forward button, it will send a character through the Bluetooth to your ESP, and if that button is sending this particular letter, it will call the forward function. Now let's come towards all of these functions, and you can customize the buttons as well. In the many of the apps give you this feature. So let's come toward the forward function. Very easy. The first 2 lines are just telling the speed, right? And this is the main logic. I told you before that we will put one of the out one as high and the other one as low, so that there is a polarity difference, and then the current will move forward. The motor will move. So we have put in 1 as high, in 2 as low. Similarly, in 3 as high, in 4 as low. And for the backward, what we will do, we will just reverse the polarity so that it can move in reverse. That's it. So we will reverse the polarity, and you can see the thing that was high before, in 1 was high before, it's low now. In 2 is high now. That's it. Same for in 3 and in 4. So this is the code for forward and backward. And for writing the code for stop, we will just put all of these as low or just high. So there is no polarity difference. That means the motor will stop. So the code for stop is this. Just put all of these as low or high. That means the motors won't run. Then we have to see the code for left and of course for right. Okay, this is a bit tricky, and this the logic for left and right can change. Many people write it in many different ways. So the logic that I have used is I have stopped one wheel and the other wheel I've kept it going. So what do I mean by that? Let me show you. So the logic is basically that you have 2 wheels connected on the chassis, and when I want to turn left, I will keep this wheel moving forward. This is the right wheel, right? This is the right wheel, this is the left wheel. I will keep this wheel moving forward, and I will stop this wheel. So what will happen is it will of course this is connected via chassis, right? So this side will try to move forward while this side is not moving. So definitely the car will turn towards left. This is how it works. And similarly, when I want to move towards the right, what I will do is I will move this wheel, and I will move the left wheel forward. This will move, and I will stop this wheel. That means they are connected to a chassis, so the left wheel will move forward while this one is not moving. So the car will try to, go like this. So definitely it will turn towards right. So this is the main logic. Many people use different kinds of logic. So for example, some people will move the left one forward and right one backward. That is also done. Left one forward, right one backward. You can do that if you want, but I like the other one better. And same for the case with left one. For if you want to move towards left, some people move this one forward and this one backward. So it depends on you, whatever you want to use. I like the other one better. So this way, the left wheel is not moving and the right one is moving. So when the right one is moving and left one is not moving, the motor, the chassis of the car will turn on the left. It will pivot on the left wheel and it will start turning towards the left. And same is the case with the right. When the left wheel will keep moving and the right one won't move, that means left will try to move forward and the right one is not moving. That means the car will turn right. That's the logic. That's it. You have learned how to make the circuit diagram and you have learned how to make how to write the code. So that's it. Now I will move towards assembling assembling my car actually, and I will put that in a fast forward motion. If you have understood it and you don't want to see it, you can just skip the video from here, and if you want that, you can just see it in a fast forward motion. Okay, that's it. I will upload all the code and everything in the description, and I've tested it with these two apps. You can use any of the app you want, or you can use these ones. This one was customizable as well, Bluetooth RC car control DIY by this company. Okay, so one last thing. Why have we kept the speed between 0 to 4095? I mentioned earlier pulse width modulation. Basically, it's a 12-bit channel, the one we are working on. So 12-bit channel 2 power 12 is 4096 and minus 1. That makes it 4095. Um, I'm not going into the detail of it because I've kept this tutorial very short. So if you uh, if you don't know about it, you should just know that the speed is kept between 0 to 4095. And if you want to know about it, please read in depth about PWM and how we give analog signals, and with ESP32, how do we manage that. Please read that.